All right, lesson 3 is about translating lines. Last time we learned about translating shapes, and now we're just going to look at what if we translated a specific line. Okay? Now, there are lines in shape, so we can take a look at lines being translated just by even looking at the shapes that we translate. So let's say I translated this image, this pre-image, to become this image by the vector hi. Now, of course, the shape moved down, but also each of those lines moved. Now, because the shape is the same and we looked at what was preserved in the last video, we also know some certain things about this shape. So let's say that this line up top here, the one that makes up the very top of this shape up here, let's say that this line, we're going to call it A. And let's say this line down here that makes up the bottom is called B. Now, in this shape, A and B are parallel. Okay? So what would that mean about this side and this side? Well, first let's label these sides. Now, this side was A that got translated down, so we call that A prime, and we write that with a little mark at the top. And this line got translated down to be this line, so that one is B prime. So the question is, if A and B are parallel, when they get translated, are they still parallel? And the answer is yes, of course they are, because none of the angles changed, so these should still be parallel as well. So let's get that written down. Lines are still parallel when they get translated. So if they start as being parallel, they're still parallel after being translated. Okay. Also, you might take a look and see that all 4 of these are now parallel together. And it might be hard to tell because they're in shape form. So let's take a look at them in just line form. So here we have parallel lines that are being translated. So we took away the whole shapes and everything else connected, and we just are looking at the lines. So let's say we had 2 parallel lines, line 1 and line 2, that get translated by vector AB to become L1 prime and L2 prime. So in the same way that these 2 were parallel from the beginning, these 2 are parallel also. Okay? And now all of these are actually still going to be parallel to one another. So let's get that second part down. The resulting parallel lines from translating parallel lines are parallel to the first set of lines. That's kind of a mouthful, but it just means that all these are going to be parallel to one another. So we took parallel lines and translated them. And that is all of lesson 3. Lesson 3 is just about the fact that things stay parallel when you translate them. And actually, if you translate a line to a line, those 2 lines, the pre-image and the image of the line, are parallel. This is lesson 4 on reflections. Now, reflection is a type of a symmetry where the figure is reflected across a line, creating a mirror image. And most of us are pretty familiar with that concept. When you reflect something, of course, you get something that's very similar, but just flipped around, essentially. Okay? So let's take a look at what that looks like in geometry. So let's say I had this figure A, and I want to reflect it across this line. Okay? Now, since it starts 1 block away from the line, my image is going to also start 1 block away from the line. Okay, so the reflection would look like that. Now, what do we call this? If the original figure is A, then our image at the end is going to be A prime. And that's pretty much what reflection is. You're just reflecting it across a line, which essentially gets it flipped. Now, there's different names for this line. So let's get all those down just in case any of them pop up. You're not going to be confused by what they're talking about. So you might hear people, or just in your instructions, say, call this line the mirror line, the line of reflection, the axis of symmetry, the reflection line, the axis of reflection. It's all just the line you're reflecting across. Okay? But you might want to write those down so when you see those words pop up in your instructions, you can look back and be like, wait, or is that really just that line? And most of the time, yes, it is that line. So now, it's all fine and dandy to flip something across that way, but what if we reflected down instead? What if our line of symmetry was this one? Well, now, in this case, because our figure was 2 blocks away from our line of symmetry, then our next image should also be 2 blocks away. So we're going to start down here, and it would get reflected like that. Okay? And again, since this was A, this would be A prime. What if I reflected it the back way, going backwards? Let's have this one, I don't know, be 3 away. Well, since this distance is 3, then our reflected image is also going to be 3 away. And again, it would be A prime. So you can see that the reflection line is very similar to the vector for translation. Our reflection line tells us where that image is going to end up. Because if I just have a starting figure and we're told to reflect, we don't know where it's going to go or how far out until we have our reflection line. And based on where our reflection line is, it can kind of end up almost anywhere. Okay? It's just going to end up flipped, essentially. Now, there are some very interesting properties that happens with our reflected image in our image. If I were to draw a line from the original point to the reflected point, the line is perpendicular to the reflection line. That's true of all of them. Check it out. If I go from the original point to the reflected point, the line between them is perpendicular to the reflection line. So let's write that down. Okay, and I apologize that that's kind of hard to see. A line drawn between a point and its reflection is perpendicular to the reflection line. A line drawn between the point and its reflection is perpendicular to the reflection line. And that's going to be true always. See, even if I did it over here, the original point to the reflected point, these lines are perpendicular. There's another thing that happens because of this. With this line drawn from the original point to the reflected point, the reflected line cuts it in half every single time. So here's our point, here's our reflected point. You can see that the reflection line cuts it in half. Same thing down here. Point, reflected point, the line is getting cut in half by our reflection line. So let's write that down. The line drawn between a point and its reflection is cut in half by the reflection line. Okay, so the line drawn between the point and its reflection is cut in half by the reflection line. So let's now take a look at this reflection and use it as an example to see what is preserved during reflection. Okay, so we have a checklist over here. We need to see which of these is preserved and which ones are not. So first on our list is the size. Is the general size of the shape still the same? Like if we found the area, would this area of this be the area of this one? Well, yeah, they're still the same thing. All it did was get reflected. So size is still, yes, the same. What about the shape? What is a trapezoid is still a trapezoid, and what's a rhombus is still a rhombus? Yeah, the shape is still there. It just got flipped. So it's still the same shape. What about the orientation? Is a particular point still pointing in the same direction? Is this point right here still on the, I guess for you, the right side of the shape? Well, no, now it's on the left. So orientation does not stay the same. What about parallel lines? Any parallel lines in the beginning one, like this one and this one, or how this one's parallel to this one, are those still the same over here? Well, let's take a look. This one, yeah, is still parallel with that one, and this one is still parallel with this one. So yeah, parallel lines are actually still kept the same. Any parallel lines that were parallel to each other are still going to be parallel after they are reflected. What about the angles? Are the angles kept the same? Well, they might have changed positions, but they are. So this angle is still going to be the same measure as this angle. Or this angle is still going to be the same measure as this angle. So angles are kept the same. What about line lengths? If this bottom length down here was, I don't know, 5 inches, what would be the length of this side? Well, we'd still expect it to be 5 because all it did was get reflected, but it's still going to be the same length. So a lot of things are kept the same, just like in translation. The only thing that's getting changed is the orientation because we're flipping it. We're now going to look at what happens when you reflect a figure that's on top of your reflection line. Okay? Now this one might be hard to just draw off the top of your head, so I would suggest that you go point by point, and obviously use different colors so it doesn't get too confusing. Okay? Now this point right here is 1 away from our reflection line, so it's going to be 1 away on the other side. What about this point? Well, this point is 2 away from our reflection line, so it's going to be 2 away on the other side. Up here, this one is 1 away from our reflection line, so it's going to be 1 away on the other side. Now all we have to do is connect those dots. And that's exactly how a figure on top of our reflection line would get reflected. Now, a simpler example of this is if the reflection line goes right down the middle of something that has what we call symmetry. So let's take a look at that. So what if we had something that has symmetry, meaning both of its sides are exactly the same, and we have our reflection line going exactly through that middle? Well, what would the reflection look like? Well, let's go point by point. This point is 2 away, so it's going to be mapped on the other side 2 away. This original point was 2 away, so it's going to get mapped on the other side 2 away. This point is 2 away, so it's going to get mapped on the other side 2 away. And this point was 2 away, so it's going to get mapped on the other side 2 away. And a lot of you can already see what's coming. If you draw that out, you're drawing it exactly on top of your original image. Okay? And that's okay, because when you have something that has symmetry like that, and you have your line of symmetry going through the exact middle, it's just essentially getting flipped over. Okay? And that's how we define something having symmetry, that your line of you could reflect it across the exact middle, and it looks exactly the same when you reflect it. And that is all that we're going to go over for reflections. We'll do a lot more practice in class.